Okay, good morning everyone. Can you hear me? Am I on either?
Yes, sir.
Okay. Last day, we tried to understand about how to compute the limit, right? Computing of limits. That means there are no such unique method to compute the limits because we have different kind of functions. So if you are dealing with different kind of functions, we have to identify a way to compute a limit. At some point, we can have or we can find the limit. At some point, we cannot find the limit because limit sometimes does not exist. So we have to prove it. So we are go through the basic concept and we are showing that at that point when the number approach to that value, then sometimes the limit may exist and we can prove that value, and sometimes limit may not exist. That's simple. That's all. So in computing of limits, I told you to put into your memory this step, some logical step. That is, if it is a polynomial, we prove that we can suddenly find the limit by plugging the values to that polynomial. And if it is some kind of rational, then you have to do something more. That means if you plug in the values to the that rational, then if it is 0 divided by 0, definitely it is a whole. Then you can find the factors. Then you need to find the factors and simplify the function. After that, you can have or you can do by or find the limit at some point, but it's not valid for each and every time because at some time, even you find the factors, you cannot find the limit. Sometimes limit does not exist. So that's the things we did at the last day, right? So today we have to continue that part. So basically, uh, we compute the limits on polynomials and some rationals or their root functions, root functions, right? Anyhow, there are so many functions we have to learn to compute how to compute the limits on that. So the thing is, we have the next function is piecewise function. So we need to understand how to find the or how to compute the limits on piecewise function. So let's try to do this. Okay, that is not much heavier to understand because to compute the limits in a piecewise function, only need to uh, see the limits or happen in the point. That means when you approach to some point, you need to look at the left hand side and the right hand side. What happened to limit? That's concept you have to use when you are dealing with the piecewise function. Okay, let's take some example and try to understand the happening inside it. Let I define some function. So in the piecewise means the function is changed in a separated x values, right? So let's do this. You can have when x is less than -2, function behave as 1 over x plus 2. That is a one function. Then let's define another range to -2 to +3, like that. So then function behave as like this, x squared minus 5. So there are so number of functions may have only piecewise. So the meaning of that, under one range it behave in one function, and under another range it has another function. Let's take something hard cake. This has 3 parts, right? This one behave as square root of x plus 13, right? We have 3 functions. Let's put name for that. This is f1, f2, f3, right? So there are no worries in between the locations within the range, but the only thing is we have to consider the limit is very it might be hard to find when you consider the point as like this combining point, end of the one function and starting of the other function at location, right? So sometimes the limit does not exist or exist. You have to find out it. So piecewise function as like this, right? Okay. Then our target is we need to find the limit when x approach to -2. What happened to this piecewise function? This is our target, right? Okay. Then the thing is we have to think in the very basic format. So if we need to find the limit when x approach to some number, then we have to find, or we have to look at the left hand and the right hand. You have to come from left hand and the right hand. Then we can see if limit is exists, then these two are equal. If it is not, means that at that point limit does not exist. That's the very basic concept of the limit. So let's do that for this, right? So first we have to look at the limit of fx, right? When x approach to -2 in left hand. That is why I put the some minus signature here, right? This one we need to evaluate, right? Another next thing is limit of fx when x approach to -2 from the right hand. This one need to be evaluated. If these two are equal, means there is a limit and we can find the limit. Okay. Now tell me, now we are looking at from the left end of the -2. So in the number sequence, this is -2, here +3. We are look at from this end, right? Next first. Then we have to look at from this end, right? Then we need to see whether the limit is exist or not, right? So now tell me which function, what I need to use to compute the limit when I coming from the negative end to -2. Which function need to consider. There are three functions because these are piecewise functions. I'm looking at that here.
F2.
Which one?
F2.
I'm coming from the left end.
F1.
Yes, that means I am at here. That means below than the negative 2, right? So in that content, we have to consider this function. That means f1. I'm look at here, then I need to consider f1. If I look at, or if I am here and coming to the minus 2 from right end, that means I need to consider this f2, right? You know f1 and f2 because I know put a notation that f1 and f2 for this function, right? That's the things you have to do, right? So that means I can write here, instead of fx, I can write here f1 or 1 over x plus 2, right? In here, I can write, instead of fx, f2, that means x squared minus 5. Okay. First, I will solve this end because this is polynomial. So you can just plug in the value for it and find out the limit. If I substitute number negative 2 here, that means to negative 2 to the power 2 means 4. 4 minus 5 means 1. 4 minus 5 means negative 1. Right. We have an answer for that. Right. Now we need to see whether this end will give the result as same as the positive side. Let's check. Now this is a rational. So very first step is just plug in the value and see what's happened to the uh, value of the function. Then when I substitute negative 2 here, then 1 over 0, right? You know that that is not the whole, that is asymptote. So you have to find out a way to handle. But in here, you can see you cannot do anything in that position because we cannot simplify this one. So just try to do some analysis whether we know that this is asymptote now, negative 2, uh, when we considering the f1 function. So we have to see what happened here because we can see when I substitute negative 2 here, 1 over 0 means it goes to infinity. So just we need to find out, we know that it goes to infinity, but we don't know whether it is negative infinity or positive infinity. For that, we can substitute some number just below than the negative 2. Let's take negative 5 like that. Then put it here. That means negative 5 minus negative 5 plus 2 means 1 over negative 3. Right? That means it is a negative value. So you can understand whether this graph how goes to the infinity. So it comes from the negative end and go to negative infinity. Right? So we can draw that graph as like this, but from the when you come the right end, it's just focus or converge to the minus 1. That means it has the limit, but these two are not equal, right? These two are not equal. So you can write now when x approach to negative 2, the limit of the fx is does not exist. So in this example, we cannot see the limit at the negative 2. Right. As like this, you can find the limit, or what's happened to limit at positive 3. Can you do this? Concept is same. I forgot to tell you, please find the attendance by just putting your index number in the chat box. Now, what is the case? Just we have to do. Now we have to consider limit at positive 3, right? That means we have to just look at the limit of fx from the negative end of 3 and the positive end of 3. So you need to identify the correct function that's relevant to the side you are just looking. That means you are looking at point number 3. So you are coming from left hand means you need to consider the function called f2. When you're coming from the right hand, you need to consider the function called f3. Right. Now this should be very simple one. So you just plug in the value. 3 square means 9, 9 minus 5 means 4. Here also, no matter, you can just plug in the value, right? Not any barriers inside the square root, right? 13 plus 3 means 16. Square root of 16 means again 4. Now you can see these two are equal. Right? So you can just write limit of fx when x approach to 3 is equal to 4. Is the answer. So at the number 3, it has limit, but at the negative 3, doesn't have the limit. That's the answer. Please note down this one. Okay. So next thing, now you know about piecewise function, how to uh, behave a piecewise function when you are computing the limit. So next thing is, then we have to find the limits of each function. This one is something hard. Okay, limit of trigonometric function, trig function, right? So in here you have to something learn some points or methodologies to compute the trigonometric functions, because uh, time to time, that means one problem to another problem, you have to learn something more. So not like the previous case. So try to understand well this. So in an earlier day, we uh, learned some basic concepts of the uh, computing of limits. Then we understand some properties of the limits. Then we can apply that properties to computing the limits. Likewise, in the when we find the limits of the trig function, then again we have to uh, learn some basics. Then we have to keep it in mind. We have to store that in our memory. Then directly we can use that proof or verified general computed limits into in a some hard problem. So that's the idea. So let's start from the beginning. So you know that we have very basic uh, trig function, that is sin x and cos x. You know these are continuous functions, continuous everywhere, right? There is no breaks inside this, right? So these are continuous. So in when we compute in the limits of trig functions, again, as we used earlier, we in the mathematics, right? They have shown that limit of sin x when x approach to some defined number, right? Some constant, we can write this directly, just plug in the value as the previous very basic things what we have learned, right? Likewise, the polynomial, right? We can apply that concept to trig function with sine and cos function as like this, right? Not all the trig, right? For sine and cos, this is valid story, right? When you need to find the cos x when x approach to a, then you can just plug in the value for that, right? This is valid. So you have to use this property, right? We are not going to prove, just we can just use to further uh, problems, right? Then you only write here sine and cos. Then what happened to tan? What happened to tan next? If these two are okay, then you can find what happened to tan x also, because tan x means sin x over cos x, no? So limit of tan x when x approach to a, right? You can write like this: limit of x approach to a, this one function you can write sin x over cos x, right? Then you can apply some basic properties of limits. You can, if this is a division, no, so you can apply the limit for separately for this limit division. That's the basic. So you can write limit of sin x when x approach to a, or limit of cos x when x approach to a, right? Now what happened? Now you know what happened to sin x when x approach to a, and what happened to cos x when x approach to a. So you can just plug in the value. Then this one should be sin a, this one should be cos a. But in here you have to note down something, because cos a is in the as the which one, numerator or denominator? Denominator, no? So when we are just writing the division part, we cannot set denominator as 0. So you have to write something more, cos a does not equal to 0. Under this condition, this one is valid. So we can just write sin a over cos a. You can write tan a. Okay. Now you have something very beautiful one. When limit of tan x when x approach to a, right? You can just plug in the value for tan also, just like the sign, but we have a condition, cos a not equal to 0. So that means a should not equal to what? Cos 5 over 2. What is the value of cos 5 over 2? Cos anuva kiyada?
0.
Yes, like that. We have to remove that point, 5 over 2. Then we meet again it 3 5 over 2, like that. So at that values we have to remove from the range, right? Sorry, domain. So not only positive 5 over 2, we have to remove negative also. Therefore we can write this one, right? When a is not equal to this value, then and only we can write tan x when x approach to a. Just you can plug in the value for the tan function, tan a, right? This is the very basic uh, concept of limit in the very basic trig function, that is sin for sin x, cos x, and tan x. You have to keep this in your mind, right? You have to store it. Okay, I delete the plot. All right. Then from examples, we have to find out the different ways of solving the trig function. So first, let's take this kind of one. Limit of, we have a cos function inside the cos, we have this one. We have to find the limit of this cos function when x approach to 1. This is the question, right? This is the question. So how we handle this one? So you know that this one is some kind of rational, right? And also you can define inside rational there are two polynomial division of two polynomials likewise. So in here you can see the composition of function, right? Inside the construction again we have a function, right? You can see this. So in limit, right, we can if we can use this technique to elaborate or to solve these kind of when the functions are compositions in the trig function and the other function. That means there is no matter we can set or bring the limit to inside this uh, function, right? So first I write the thing. This one is valid. So why this one is valid? Only because cos function, right? Cos x, this one is a very basic function. This is continuous function, right? This continuous function, right? So in here we see the composition of function, right? Composition of function. So if the cos function is continuous, right? We can do this, right? If this one is not continuous, then we cannot do this task. But in here, cos means at the beginning I told you sin x and cos x is a continuous function. Continuous means there is no break inside because in each and every value, right? In the x, you have a y value, right? If it is sin or cos, this doesn't matter. In each x value, you can find the y value. So it is continuous, right? There is no whole or asymptote in this cos function, no sine function. That's the meaning of continuous, right? So if it is continuous, we can apply this concept. That means uh, instead of so in here we cannot do or we can solve this problem, but uh, we have to use this method. That is, if this cost is continuous, so we can apply this technique because this is now functions are composition mode. So we can find the limit of this function and we can solve the situation. So in here now we can solve this, right? Because we know how to find the limits of here. So let's do it. So first one is you can just plug in the value 1 1, then 0 divided by 0, that means that is whole, right? If it is whole, you can find the factors, right? So in here x squared minus 1 means x minus 1 x plus 1. So you can uh, remove x minus 1 from the, and then remaining part is x plus 1. So you can write this one like this, and next first one x plus 1, right? Now this become x plus 1 means you can just plug in the value, that is 2. Okay, this is the answer. Limit of cos x squared minus 1 x minus 1 when x approach to 1, answer is cos 2. So you can use this method to solve this kind of problem, right? So if in here sine also, you can do this. If in here cos, then you can do it. Let's take another example. Limit of our function is just like this. 3 squared plus cos x. You have to find the limit of this function when x approach to 5 over 2. Right. So now it is easy. So you can apply the very basic concept first. So you can separate the limits from this addition first. After that, here this one is polynomial. This one is continuous, very simple trig function, that is cos x. Now you know how to apply the limit for that one and apply the limit for this one. You can solve that. Tell me the value. What is the value for cos 5 over 2?
0, 0.
Right. Then this one is 0. Then the remaining one is 3 5 squared over 4. This is the answer. Okay, now we are going to oh, yes, we are going to learn something very special case, right? Right. I will just write the example for that. Can you find the limit of sine x over x when x approach to 0? So any function, so any problem that you have to find the limit, then first one is just plug in the value. That's your first technique. right? So what happened when you apply or plug in the value to this value, this function?
Undefined.
Yes, what is the, that is
Zero.
0 divided by 0, right? So this one becomes 0 divided by 0. Then I told you earlier, if it is 0 divided by 0, then what you have to do?
Factorize.
Yes, I told you find out the factors, right? But in here, can you find out the factor to simplify the function?
No.
No, right? Now this one is very critical. You are stuck at this point, right? Because we cannot solve now from our knowledge, because basically we are trying to apply in the theories that we learn, but in here we just stuck. So in this kind of trick function, that is very useful point. So we have to learn how to what happened with the limit of sin x over x when x become to 0, right? So to understand the things, now we are going to do something just like drawing, right? Now we are going to prove some point using the geometry, right? I will draw some portion of the unit circle from the first quadrant, that is early now. So this one is unit circle. Unit circle means it has the r is equal to 1, that is unit circle. So in here, I think you remember earlier also I used this kind of thing in the introducing of trig function. Right, this is good. Now we are going to consider some areas, right? That is our target. So I'm going to draw some triangle and try to compare the areas, right? So this is second one is this one. This one, these lines are perpendicular to here, right? So we use another color. Okay, now I'm going to use this triangle and this vector as well as this big triangle. Now you can identify the three areas, right? So I'm going to write the area. Right? So at first I will take small triangle, then sector, then big triangle, right? Okay. To I'm going to consider area now, so I need to know this length to find the areas of these triangles and sectors also. So let's try to do this. So I will consider some angle of this line. This one I will note down as x, right? This is x. Okay. Now you have to find out length of these uh, triangles, right? So in here, you know that this is unit circle. That's I can put number one here. This is unit, and as well as this length. What is the value of this length?
1.
It's also 1, right? Then this is angle x. So tell me the height of this line. Can you tell me a value for this? Using this angle and any of this line, length of this line, you can express the value for this height.
R sin x.
Yes, what is the value of r? R is equal to 1. This is unit circle, no? So this one is r is equal to 1. So yes, you can write r times sin x means 1 times sin x means sin x. So this one is the height is sin x. Then this one cos x. Okay. Then we need to find out the value for here, value of here, this height. Can you do this? How to find this height? Just use the trigonometry. Using this base, that means according to this angle, this is adjacent, right? Adjacent, this one, maybe this angle you can use. You need to find the height of this. So using this triangle, you can express height for this. How to use? Just take the tan x, right? What is the value of tan x? Since this is unknown, I can put y here. Then y over what? Tan x. Y over
1.
1. Opposite over adjacent. 1. That means y equal tan. Right. This is well enough. Now I can write the area. Small area. Small area means this red color one. Can you tell me a equation for this area to find out this area? What is the value of area? Now you know all the details. What is the value?
Sin x over 2.
Sorry, sin x over 2. Right,
Yes.
how to write it? Half time length of this, that is 1, and the height, that is sin x. So this one is equal to sin x over 2. Good. Then let's first write the area of the triangle, big triangle. Half times 1 times what? Tan x. So this one is tan x over 2, right? Now tell me how to find the area of this sector. How to find the area of the sector? What's the equation?
360 divided by x basket.
So you have equation, no? So when you need to calculate the area of the sector, you should know this very basic mathematics, right? So you can just write half, then r squared theta. This is the equation for area. You need to find the area of a sector, right? So this one need to remember, right? So just apply this. R is 1, theta means x. X is in radians, okay? Then so you have answer for this x divided by 2. Now you have 3 values, but in geometrically you can see something here. You have a small triangle, then sector, then big triangle. You can apply something because you know area. When you see this, the area of the small triangle or area of the sector is greater than this small triangle. You can apply this inequality sign. As well as the area of the big triangle is greater than the sector area of the sector. So you can apply a inequality like this. So this one is still valid. Okay, now I will do some tic tacs here. Now I am divide this all the terms by sin x. before that, you can see uh, in this equal signs, you can remove this part also. Each and every one, you have a half. So you can remove this one and you can write a simplified version of this. Then after that, I'm going to divide all the terms from sin x, right? Okay, that means sin x over sin x, x over sin x, tan x over sin x. So sin x over sin x, I can write 1 here, x over sin x, right? Tan x over sin x. What is the simplified version of this? Tan x means sin x over cos x. Again, divide by sin x means you can remove the sin x, then you have 1 over, remaining is 1 over cos x. Right, now we are at here. Our target is, we need to find this term, sin x over cos x. But in here, we have x over sin x. So what we can do? We need to take the, we need to change the position. No? So we need to take what we call reciprocal, right? Of each one. Reciprocal කියන්නේ මොකද්ද? අපි මේක උඩට මාරු කරනවා කියන්නේ. right? ප්‍රතිපදය ගන්නවා කියන්නේ. right? ඒකට තමයි reciprocal කියන්නේ. ඒතර ප්‍රතිපදය ගන්නකොට inequality sign එකේ change එකක් වෙනවා. මේක mathematically වෙන දෙයක්. right? If you take a reciprocal, so you need to change the direction of this inequality, right? So in here, if you take the reciprocal of 1, again it remains as 1. To take here x over sin x, then you can write sin x over x. In here, you can write cos x. The point is, you have to change the direction of this inequality. ඒක වෙන්නේ මෙහෙමයි. ඔයාලා නිකන් හිතුවොත් if you consider number 3 and number 5, so you can write like this way. If you take a reciprocal of those, that means 1 over 3, this is 1 over 5. Now just think about that. If you remain the inequality sign like this will wrong. Why? 1 over 3 is here 1 over 5. 1 over 3 is greater than 1 over 5. So you need to change the direction. So that concept we need to apply when you take the reciprocal. So we need to change the direction of this inequality. Okay. Now we have our term. So what we can do? Now let's take limits of each and every term. Limit of 1 when x equal to 0. Then let's consider limit of sin x over x when x equal to 0. Then limit of cos x when x equal to 0, right? Let's apply, let's find the answer first. Limit of 1 when x equal to 0. This is a constant. It's a very basic one. So value is 1. This one is still you need to find. We don't know what is the value. Limit of cos x when x equals 0. You can just plug in the value cos 0. Cos 0 means again 1. Okay. Now you have to learn some theorem. Right? I will delete this part now because even you come to this point, you cannot solve or find out the limit of sin x over x when x equal to 0 without this theorem. Right? What is the theorem? Now you are going to learn this one. Push theorem. Right? So some people sometimes this called sandwich theorem. Right? So theorem we can express like this. Okay, let's take some functions called g, f, h. Let's take 3 functions. Right? The thing is, suppose the gx, right? Gx is greater than fx as well as hx is greater than the fx. Fx is greater than gx, hx is greater than fx, right? So we have this kind of function, and as also suppose that right, limit of gx when x equals x approach to 1 equal to limit of hx when x approach to a. Let's take some value called L. That means limit of this left is the middle function. So limit of the left function is going to L. Again, limit of the right function, right hand side function, it goes to the same value called L, right? Then we can write limit of fx when x approach to a should be go to L, because there are two functions. One is below than our main function, and the next one is something greater than our main function. We cannot find out the limit of our main function, right? So what we are doing here, we take two functions. One is greater than and other one is one is less than and other one is greater than, and we just see the limits of those functions. But we can see if these functions, even the smaller one and the greater one, also come to the one value of the limits at that point when x approach to a. So then and only we can write limit of our main function should be converge or go to the L, right? So this one is called the Squish theorem. So we cannot find the main function, limit of the main function. We don't have a way to find out the limit in the mathematical way. So we take two functions, right? Just look at the limits of that at that point, and if those are equal, then and only we can write. But these two are not equal, nothing to do, right? We cannot solve it, right? So that technique uh, called squish theorem or sandwich theorem. So I think now you have some idea about this sandwich theorem. So same thing now we are going to apply here. So we are at this question, right? So we just take the limits also, but you can see limit of 1 it is equal to 1. Limit of cos x when x approach to 0, it is equal to 1. So these two are equal. So at that content, we can write now limit of sine x over x when x approach to 0 should be equal to 1. So we prove now this, because in here we cannot have any format to solve the problem. Is stuck here. So we use some graphical representation and using some theorem introduced in the mathematics, and prove that this limit of sine x over x when x approach to 0, it goes to 1. So you need to memorize this. Further, if you have to find out limit of sine x over x, you just write 1. When x approach 0, you just write 1 until it doesn't ask the proof. Okay, please note down this part. මේක ඔයගලන්ට ඉතිරියේදී කෙලින්ම පාවිච්චි කරන්න පුළුවන්. මේක ඔප්පු කරන්න කියලා කිව්වොත් විතරක් මේ විදියට කරන්න වෙනවා. Okay, now you know the limit of sine x over x when x approach to 0. It is equal to 1. Let's use this one for example. Find out the value for this problem. Limit of 1 over cos x over x. So this is the problem. X approach to 0. Can you do this? What is the first step in computing limit? First one is just plug in the value. So what's happened when you plug in the value?
0 divided by 0.
0 divided by 0 situation. Then next thing is, if it is 0 divided by 0, try to find the factors. So can you do this here?
No.
No. Okay. Then what happens?
Let's conjugate.
Yes. Do you have some another methods also? Now, then, yes, as you explained, you can try out to take the conjugate and see there are any factors to simplify, right? But in here, even you use the conjugate, you cannot find the factors. But this is, now we are in the trig function. In trig functions, in trigonometry, you have some identities of the uh, function, sine or cos, sine function and cos function. So you can use that identity, right? Okay, according to you, I will write limit of 1 minus cos x over x. So you can choose conjugate. So what is the conjugate of this one? 1 plus cos x, 1 plus cos x. Then what happens? 1 minus cos x, 1 plus cos x. So you can write
1 squared minus cos x squared.
yes, 1 squared means again 1 minus cos squared x. Denominator we have 1 plus cos x. Okay, we bring the fraction up to this level. Now see what you can do. So here 1 minus cos squared x.
It's equal to sin x.
Yes. From which how did you get it? Because we know that what sine squared x plus cos squared x is always equal to what? 1. Then you can see 1 minus cos squared x is equal to sin squared x. So you can write sin squared x here. Limit of sin squared x here x 1 plus cos x. Right. Now we are at here. Now what can we do? So we can set the term sin x over x here because we know the limits of that. Okay. Now I'm going to separate the limit as well as I'm going to make the term sin x over x. Limit of, I will take 1 sin x. Right? Sin x over x. Again we have sin x over 1 plus cos x. I write down and then we'll do the separation part. Then I can separate the limit. Limit x go approach to 0. Sin x over x. Limit x approach to 0. Sin x over 1 plus cos x. Okay. Now you know answer for this. Sin x over x when x approach to 0, what?
1.
1. Can directly use it. Then in here, you have any problem to find the limits of here? Just apply and see if there any problem. What happened to numerator and what happened to denominator? Can you see the denominator? Is there any
0 divided by 2.
0 divided by 2? But this is still 0 divided by 2 means what? Answer is 0. So no worries. We can write down. So 1 multiplied by 0, the answer is 0. So limit of this problem is 0. This is the answer. Let's try to do another one. So now you have a way to handle the problem trig functions, because now we know the basics one, that is sin x over x goes to 1, right? So now what we are did here, we are making that term sin x over x because we know that one. We basically prove. So if we able to make that term, right, then we can solve the problem. That is the thing we did here. Let's take another example. Limit of so basically I need to tell you another one. Let's go back again. I will highlight this one. This one is very useful one, right? Limit of 1 minus cos x divided by x when x approach to 0. This one is 0. So you have to highlight this point also. If you see this part at any point, you can just apply 0, right? Like the previous one, sin x over x, that is equals to 1. Then 1 minus cos x over x, then it is equals to 0. So keep in mind this one also, right? So if you make or made this part, so you can just apply the limit value of 0 for that part. So this one is also need to highlight, okay? Then our third problem is limit of tan x over x when x approach to 0. This is the third problem. Now it is easy. You know what is the tan x. Tan x means sin x over what?
Cos x.
Cos x. Sin x over cos x. Right. Now you have the terms, no? Sin x, x is there. So let's separate that one. Sin x over x. Then you can take the limit of 1 over cos x separately when x approach to 0. Right. Now sin x over x means 1. Here, is there any problem when x approach 0 in this part?
1.
Yes, because 0 means 1. 1 over 1 means 1. Right. This is equal to 1. Then this one also again very useful one. But when tan x over x, when x approach to 0, this one also need to highlight is equal to 1. So if you see this term at any point, so if it is in the separated mood, you can apply or you can put a value as 1 when the limit of this function is at x approach to 0. Write down this one also. කලින් එක sin x over x, then 1 minus cos x over x, ඊට පස්සේ tan x over x එතනම මතක තියාගන්න ඕනේ. ඒතර ඔතන directly use කරන්න පුළුවන් ඔයගලන්ට problem solve කරනකොට. Right. Then limit of sin 2x over x. This is the problem. How to manage this one? Can you do this? We only know limit of sin x over x. Right? Let's write it here. Limit of sin x over x. Then x approach to 0. It still goes to 1. In here, need to see the value inside the sign is should be equal to the denominator part. So this one is 2 into equal. So what you can do here, right, without solving this function, sin 2x function into sin x term, we can set the denominator value very easily because it is available to change. So what we can do here, limit of x when x approaches 0, you can put what? Yes, sin 2x, you can bring down it into the term sin x terms because you can solve the sin 2x, but without solving that one, right? You can do a simple way to handle. You can bring or you can set the equal terms from the denominator part. That means you can multiply by 2 both numerator and denominator. So nothing to happen to the original function, right? So let's see now. You can take out the 2 from the limits because it is constant, right? Then, or you can write down this way, limit of x approach to 0 or 2 times limit of x approach to 0 sin 2x over 2x, right? This term very similar to this part, but we need to do something more here, right? What? Here we are looking the same variable approach to 0, but in here variable is 2x, but in here limit we are going to find x. So let's see this one. When x approach to 0, what happened to 2x?
0.
It also go to 0. So nothing to worry about that, right? You can write 2x go to 0. Okay, now all the terms are very similar, right? Like this equation. So nothing to worry about. You can put 1 here, right? And the constant is a constant. So you can put 2 here. So answer for this question is 2 times 1 means 2. So now you have idea. If this has to find something, so you can set the denominator to match that value, the angle having inside the sign. After that, you can check this limit because we are dealing with variable called x, but we have to see now the variable inside the sine function. But this one is satisfied when x approaches to 0. Again, 2x should be approached 0. If this satisfies, then we can put 2x approach 0 instead of x approach 0 because both are equal, right? Then and only we can write or put the value for this part. Then we can find out the answer for this question. Okay, let's go to another one. Limit of sine 5x over sine 6x when x approach 0. Can you do this? Can you do this? Yes, your answer is correct. Let's try to solve this. So the thing is, now you can set the sine x over x like that function. So tan x over x, so 1 minus cos x over x. That's the things you know. So in here we have sine functions now. So let's try to set that function sine x over x. So in here, first I will set sine x over x here. So for that I will multiply both numerator and denominator from 1 over x. That's the first step. Then we have terms like this sine 5x over x again sine 6x over x. Okay, then what I can do, I need to set this term to match the inside of sine function. So I can put 5 here as well as put the 5 from the numerator 1 also. Likewise, I can set 6 here and put another 6 to bring the function as remain as the same. Okay. Now separate the limits. I will not write the limits for 5 like that way, because we know when we take the limits of constants, the value is same. So I will take out 5 over 6 from the limit operation and say or write sine 5x over 5x limit x approach to 0 sine 6x over 6x. Right. You can write down this one here. When x approach to 0, again 5x goes to 0. Likewise, when x approach to 0, 6x also approach to 0. So no worries about, you can simply the number. So for this case, you know, upper part goes to 1, and lower part goes to 1. So you have the answer 5 over 6. This is the limit of this sine 5x over sine x 6x when x approach to 0. These are just example questions, so you no need to mesmerize the answers. You only store your brain or memory this one. What is that? Sine x over x, 1 minus cos x over x, and tan x over x. Value for these limits. Let's take another example. Limit of sine x squared over x. This next section. Can you do this? If yes, please tell me the answer. How to do? 0. Yes, your answer is correct. How about others? Okay, answer is correct. So let's need to know how to do this. So only thing is, in here we have a sine function. So you need to set this function according to our basic format, sine x over x format. So we have here x squared inside of sine. We cannot do anything for that. So only thing is, we need to set our denominator to match this inner part of the sine. So what we can do here, we can multiply both numerator and denominator from x. Then no harmful for our basic function, right? In here now you have sine x squared over x squared term, and we have x term at the outside. Then we can separate the limit operation. Sine x squared over x squared times limit of x when x approaches to 0. So in here, still you cannot find the limit because this term x approaches to 0 term, but inside the our format we have x squared. So let's check it. When x approaches 0, you can see x squared always approaches to 0. So no matter, you can write down x squared at this point. Or you can put a variable as a u, just like the x squared. Then you can convert this format to our original format. That means if you apply, substitute u here, then you can see the same format. Sine u over u. When x approaches to 0, you can see u also approach to 0. So this term you can write 1. Right. Limit of x when x approaches 0. What is the value?
0.
0. 1 times 0 again 0. So answer for that question is 0. Right. Next example. Find the limit of sine squared x over x when x approaches to 0. Find out the value for that. Yes, I have answer from you. Yes, 1137. Your answer is correct. Others? Yes, 1096, 1099. Answer is correct, right? Yes, you answer correct. You are Pankaj 1138. Yeah. Okay. How to do? You have to see sin x over x terms inside this function, right? That's the only method to handle the problem. Very easier one, this one. Only thing is you have to know the basics. What is sine squared x? Sometimes you know you don't have understand about this. Sine squared x, sine x squared, like that term. Sometimes you may see these two are equal, but totally wrong, right? Sine squared x means sine x multiplied by sine x. This one, that is not the same as this one. Right? Okay. Sine x times sine x over x. Write down it here. Then separate the limit as like this. In here, simply you can write down 1. And what is the value of the limit of sin x when x approaches 0?
0.
0. Then 1 times 0, answer is 0. Next one, limit of sin 1, sorry, 1 over x when x approaches 0. What's happened? What's happened? Tell me, right? I have two answers. Okay. I have one answer that is infinity, and I have another answer that is does not exist. Right? Okay. Right. First, tell me what is the value which I can take for any value of sine? Can you tell me the range? One and minus one, no? Sine function will change within this range. So if I take or consider any value inside this function, that should be the range of -1 and +1. So it never goes to infinite like that, right? So if you give an answer like that, infinity, so the thing is that is limit exists, but it is at the infinity, right? Second answer is does not exist. So let's check it. In here, we are stuck because if we apply a 0 here, 1 over 0, then this term is not defined. So we cannot understand what we can do for this, right? So for that case, another answer I have 0, right? Now I have 3 different answers. Infinity does not exist and 0, right? In here we have trouble, right? We don't have any method to simplify this one and directly tell the answer. This one or directly tell the method to does not exist. So we are this one is very terrific problem, right? So the thing is we have to understand what is happening here. So again I will draw this line because this is a sine function. So sine function should be vary with +1 and -1. So in here, variable x is at the denominator. So 1 over x like that. So you can see when you put the values here, right? This is a sine function. No? So I think you sometimes you may heard this one, right? So inside any value you can write 2 phi f mean, right? I need to bring the frequency term inside to this story. So that is why I will write down this sine part. I'll write 2 phi x 2 phi f version. So you can see this is constant, 2 phi is constant, but inside this term value, right? When x is too much larger in negative or positively, too much larger. That means let's take 1000 here. So 1 over 1000 means 1 over 1000. The value of 1 over 1000 very small. So in that case, 1 over 1000 should be equal to 2 phi f. If you calculate f here or frequency, that is again too much small one, right? So in this sine function, when the x value is larger, then it have very low frequency value, right? So your function is coming like that way. I don't know, I don't have correct one. So, but you can draw that function like that. It has very low frequency. But when you see this one, when x is very near to or below than 1 like that, let's take 0.1, then this should be equal to 5f. Then if you calculate the f, down you have some value for f, right? That means you can see f is increasing with the x value, x reach to 0, right? Here 0 is there. When x is larger, frequency is very low, but x is 0. When you come to 0 and then time, this frequency is going to higher. Higher frequency means now you have like that. When it's very near to the 0, this one oscillate very high frequency, right? You cannot define it because it is go to the infinity. 1 over x, when x reach to 0, this goes to infinity. So you cannot define exact value, but you know that this has higher frequency. When you become to right hand end also, the same scenario. Yeah. Time, frequency, increasing frequency. When you reach the point 0, it has very higher frequency, right? This is our function, this sine 1 over x function. So the thing is, when you come from the left end and when you come from the right end to x equals 0, that point, so you cannot define a value. So when you come from this one, limit of x 0 from the left end, this sine 1 over x term, you cannot define the exact value. If you can write like this way, 1 or 1.5 like that, it is okay. But in here, due to this high frequency, how can you tell me a value for that? Because frequency is infinity. Even you cannot imagine, right? At this point. So you cannot give exact value for that, right? So at the other end also, the same problem is there. You cannot express a value for when x reach to 0 from the positive end to sine 1 over x. You cannot define a exact value. So the thing is, the idea is the limit here does not exist. This one I represent graphically, but in the advanced mathematics, if you are willing to learn, right, there are some options to prove this one, like Cauchy sequence technique, like that. You can prove this limit is does not exist. But in here, we try to understand is from graphically representation. The idea is at x, when x raised to 0, the function, sine function, the frequency of the sine function, even we cannot imagine. It has infinity, oscillating, having the frequency of infinity. So at x equals 0, we cannot give a unique value for here. That's the problem. Due to that infinity of oscillation frequency. Right? That's the problem. So using that story, please remind that the limit of sine 1 over x when x approaches 0, it is does not exist. Right? So if you have this kind of terms directly, you can tell this limit does not exist. That's the story behind this problem. Okay. So anyway, you need to keep this mind, sine 1x, so 1 over x when x approaches 0, this one does not exist. This one also highlighted point. Right? Next one. Limit of x sine 1 over x. Now the function is little bit different. Limit of x sine 1 over x. Just looking of this limit problem, you can definitely you can see you can separate the limit for these two and but one is there, but other one is you can see does not exist the limit. So can you write down that way? This one is 0, then 0 times this one limit does not exist. So does not exist times 0 again does not exist like that. So we have a problem. We cannot do that kind of mathematics, right? So that means there are some unknown happening inside this function. 0 times does not exist case we cannot handle. Right? So how we handle this one? Yes, your answer is correct. I need to know how to do it. How to do this? This is the well-known part. Any sine function, they are varying between -1 and +1. We can write down at any point this because sine never goes greater than 1 or -1. They are oscillating inside these two values. So let's use that one. So this one also a sine function. So I'll write down this. This is a sine function. It always should be within this value. So a little bit different to understand your answer, right? Let's check again. Right, I write down this one. I can write down any sine function within this range from -1 to +1. I will apply it that basics uh, to this point also. Now I'm going to make that term x times sine 1 over x because I cannot handle the problem. There are no way to simplify it or any unknown method to handle this. That is why I'm using this technique. Right? Okay. I need to set x times sine 1 over x terms inside here because I'm going to use Quish theorem. Right? Okay. Then I will multiply this term by x. All the terms by x. Okay. Can I write down this as like this way? Here I multiply all the terms by x. When we consider the x might be positive term or x might be negative term. x දාන වෙන්නත් පුළුවන්, x කියන එක ඍණ එකක් වෙන්නත් පුළුවන්. We are dealing inside the inequality sign. But in that context, think about, for example, x equal to 1. If x equal to 1, that means we are multiplying these terms by, just take 2 by 2. Then no worries, this one is -2. Then x sine x 1 over x. This is +2. Inequality signs, no any harmful for this inequality signs. But let's take another one. X equal -2. Then what happens? If we apply x equal -2, In here, this is changed to positive 2. This is changed to negative 2. Now, if this unequal sign is valid for this point?
No.
No. Then we have to take care about this point. For that, to remove that problem, right? To remove that problem, let's take what? Modulus of x instead of directly x. Now what happens? If it is x equal negative 2 or positive 2, no matter if we put this value to here, it will generate a positive term, always greater than 0. So no harmful for this inequality sign. So that is why I put modulus x here. We have to consider or think about all the things happening inside here. Now this one is valid, right? Because you know that modulus always behave as like this. This is y equal modulus x. For positive values, it generate positive y values. For negative x values, it will generate positive y values. Again, this one is y equal negative modulus x. For positive values, it will generate negative y values. For negative x values, it will generate again negative y values, right? So this one is still valid. Okay. Now what we can do? Now we are going to use the squish theorem now. So I am taking the limit of all the terms. Limit when x goes to 0 is negative modulus x. Limit x sine 1 over x. X go to 0. Then limit x approach to 0 modulus x. Right. Write down the values for this and this. When x approach to 0, what happened to the modulus of x? Goes to 0. When x approach to 0, what happened to y modulus of negative modulus x? Again, x goes to 0. Now you can use the squish theorem, right? Why? From the smaller function, that the same value when approached to the same x value, it goes to 0, and the something greater than function that we are going to consider, again when x approach to the same point, that function goes to 0. So these two are equal. So using the squish theorem, right, you have to write down it. Using the squish theorem, limit of x sine 1 over x, when x approach to 0, you can write down it as 0. This one again you need to write. At any point, if you see these kind of terms, you can use x times sine 1 over x. When x approach to 0, it is equal to 0. Okay, I will give you a last exercise. Solve this one. Limit when x approach to 0. Your problem is 2 minus cos 3x minus cos 4x divided by x. Can you solve this one by knowing knowledge? This one can be solved, okay? Just tell me the answer. What is the answer?
Zero.
Yes, answer is correct. Right. Now, how to do it? How did you do it? Can you set sin x over x terms here? Or tan x over x term? What is the method that you follow?
Sine method.
Sine? How to handle the correction? These are the things what we have already known. Sin x over x term. This is well known. Then we know what? 1 over cos x over x. Then we know tan x over x, this one. And at last, we learn limit of sine 1 over x. When x approaches to 0, this one does not exist. And finally, we learn x sine x, x sine 1 over x. When x approaches 0, this one is 0. These are the things you already know. Now you can apply those. Which one do you apply for simplification of this part? So I see this one. This cos terms is there now. So I can set this function inside here. Let's try to do this here. Number 2 is there now. Number 2 means 1 plus 1. So I can separate that. 1 plus 1 minus cos 3x minus cos 4x. Then I can separate terms once as like this. 1 minus cos 3x plus 1 minus cos 4x. Now, same function, right? Now, this one is little bit very familiar for us now. So I can separate this, divide the terms into like this. Limit of when x approaches 0, 1 minus cos 3x over x plus 1 minus cos 4x over x. Right? Now you know to do rest of the part. You can set 3 here, bring the 3 there, set 4 here, bring the 4 there. Then when x approaches 0, you can check it. 3x always go to 0, as well as 4x also goes to 0. You can separate the limit. 3 times limit 3x approaches 0, 1 minus cos 3x, 3x plus 4 limit of 4x, when 4x approaches 0, 1 minus cos 4x divided by 4x. Okay, what is the value of this? 1 minus cos x divided by x when limit of x approach to 0, what? 1 or 0?
0.
0, right? So these terms you can write 0, these terms you can write 0. So 3 times 0 plus 4 times 0, answer is 0. So this is the answer. Okay, so this kind of matters, so questions you should have to handle, right? So I did lots of exercises. So using the exercises, I gave you some methods that can be used to solve the problem. So I hope you all got this technique to understand the limit, computing of limit. So today we did piecewise functions, computing limits of piecewise function, and basically major target is considering the trigonometric functions. So we did it now. So next day we have to approach or go to the new concept in the calculus, right? So I hope all of you got understand this one. Do you have any problem? You can ask. Otherwise, I can close the sessions for today. And the extra class, right? So yeah, last day I couldn't manage that day, and this Friday also I have totally busy. So it, let's try to find out the extra day on not next week, later. Let's try to do extra classes, right? I will inform a day for that. Okay. Then is it okay to close the session today? You do understand this one? ඔයගොල්ලෝ මේක තේරුණාද මම මේ කතා කරපු area එක ඔයගොල්ලෝ pick කළාද? කියන්න බං කතා කරන්න බං පොඩ්ඩක්. මුකුත්ම තේරුනේ නැද්ද නැත්නම් මොන හරි දෙයක් ඔයගොල්ලෝ absorb කළාද මේ period එකේ? මේ කතා කරපු දේවල් ගැන. හවුද නැද්ද? තේරුණේම නැද්ද මොනවක්වත්? කියන්න.
Recording stopped.
උත්තර නැහැනේ. Okay. The sum level you can understand. But some portion is there. They still try to understand, need to do lot. Okay. Right. Someone asked to do extra tutorial classes, the thing is not like the conventional lectures. Here I put lots of examples, right? So this one is just like the tutorial class because normally inside the lectures, normally we did not this number of examples, right? But to understand this mathematical concept, so that is why I am using lots of examples to give you the basic knowledge. So I think using the examples, we can do more. Yes, I will do the references books, right? I will tell you to refer the books really related to our level, right? I will next day I will do it. නෑ එක්ස්ට්‍රා ක්ලාස් එක මේ සිකුරාදා නැහැ මේ සිකුරාදාත් මම totally busy මේ දවස්වල ගොඩක් වැඩ වැඩි මොකද ඔයගොල්ලන්ගේ බැච් ඔක්කොම මේ එක දිගටම රන් වෙන නිසා දැන් ටයිම් එක හරිම අඩුයි මේ වැඩ ගන්න මොකද පේපර් මාකිනුත් තියෙනවා සමහර බැච් වලට ආපහු එක්සෑම් උත් වෙන්න හදයි ලෙක්චර්ස් යනවා ඔන්ලයින් යනවා ප්‍රැක්ටිකල්ස් යනවා මේ දවස්වල ටිකක් සම්පූර්ණයෙන්ම මේ අනිත් පැත්ත ගහලා තියෙන්නේ ටයිම් එක මැනේජ් කරන්න ගොඩක් අමාරුයි ඒ නිසා මේ සිකුරාදාත් නැහැ බලමු ඊට පස්සේ සිකුරාදා කරන්න පුළුවන්ද කියන එක මම ඔයගොල්ලන්ට කියන්නම් then okay, thank you very much for joining to the session. So anyway, I will try to explain some theories greater than this level, right? Okay, then thanks again. Okay, I will close the session now.
Thank you, sir.
Okay.